In this question, the number of pika in a region is decreasing. How does it decrease in the pika population after 4 years? So, first of all, ladies and gentlemen, what is the initial population? Is now there are 144 pikas. After 1 year, because pika population are decreasing 8% each year. So, what is the population after 1 year? To be able to find this, first of all, how many pika is going to be decreased after 1 year? We need to find that. So 144 times 8% is going to give us how many pikas are going to decrease. The number of the decreased pika population you can find from here. So if you calculate this, you will get 144 times 0.08. This is the number. If you subtract this from the 144, you are going to understand exact the population after 1 year. So what am I going to do? If I get the greatest common factor parenthesis 144, you will get 1 minus 0.08. This is the population after 1 year. Population after 1 year. What about the second year? What am I going to do? First, I am going to find 8% of this population. 144 times 1 minus 0.08 times 8% is going to give me how many more pikas are going to decrease after the second year. So you can say 144 times 1 minus 0.08 times 0.08. If we subtract this from the previous population, which means that 144 times 1 minus 0.08 is the total population after 1 year. If we subtract how many pikas are going to decrease, which is 144 times 1 minus 0.08 times 0.08, if you get the greatest common factor, parenthesis, you will get 144 times 1 minus 0.08. This is what? This is the greatest common factor. Then what's going to be left? 1 minus 0.08. So these are the same factor. That's the reason we can write 144 times 1 minus 0.08 to the power 2 is going to be the total population after the second year. Total population after second year. Now, what I noticed that there's a pattern. What do you expect after the third year? I am after the 3 year. I am going to expect the total population 144 times 1 minus 0.08 to the power 3, and fourth year, what am I going to expect? 144 times 1 minus 0.08 to the power 4. So if you calculate this, you are going to find that, ladies and gentlemen, 144 times 1 minus 0.08 is 0.92 to the power 4, which is equal to 144 times 0.92 to the power 4, which is equal to approximately 103, is going to be total population of pika after 4 years. So what I noticed here, ladies and gentlemen, this is going to be initial value, this is going to be growth rate. This is going to be actually decay rate because there's no growth here. That's why this is decay rate. And this is going to be decay factor. This is initial value. If you generalize this, you can model exponential decay with a function of the form f of x is a times b to the power x. A is going to be greater than 0, b is going to be between the 0 and 1. Decay factor, this is important, decay factor is 1 minus the decay rate. So, as you see here, ladies and gentlemen, R stands for decay rate. 1 minus R stands for decay factor. Next. The yearly profits of a company is 25,000. The profits have been decreasing by 6% per year. Write an exponential decay function to represent this situation. First, remember that f of x is equal to a times 1 minus r to the power x is decay, exponential decay formula. R stands for decay ratio, decay rate, not ratio. 1 minus r stands for decay factor. Now, let's substitute everything into the formula. What is the initial amount? 25,000 times 1 minus, what is the yearly decreasing percentage? 6%, which means that 6 over 100 to the power, so x we don't know right now. So if you write this exponential decay function, 25,000, 1 minus 6 over 100 will be 0.94 to the power x. So this is exponential decay formula. This is part A. What about the part B? What will be the profit? What will be the profit in 8 years? Round your answer to the nearest dollar. So what am I going to substitute into the x? 8. Substitute. F of 8, which means that the profit in 8 years, 25,000, 0.94 to the power 8. From here, if we calculate this, 25,000 times 0.94 to the power 8 will be equal to the nearest dollar, which means that 15,239. This is to the nearest dollar, approximately. This is your answer. Next. Determine whether each table represents an exponential growth function or exponential decay function or neither. Ladies and gentlemen, to be able to understand exponential decay or exponential growth, you have to make sure that, remember, what is the formula, exponential function formula? F of x is equal to a times b to the power x. This b, if is greater than 1, then we will call exponential growth. If this b is between the 1 and 0, then we will call exponential decay. Exponential decay. Now, let's look at this. When you look at the x and y values, x values are increasing 1. While x values are increasing by 1, what about the y values? As you see here, multiply by 1/3. Multiply by 1/3. multiplied by 1/3. You can also understand what is the initial value here is 270. So substitute f of x is equal to 270 times b to the power x. To be able to understand what b is, you can substitute one of the ordered pair into the function. I would like to choose this part. This is the ordered pair. 1 and 90. If we substitute this, what is the y value? Is 90. What is the x value? Which is 1. Substitute 90 is equal to 270 times b to the power 1. From here, if we divide both sides by 270, you will get that b is equal to 1/3, which is less than 1 and greater than 0. That's why this is exponential decay. The first exponential decay. What about the next one? Same idea, f of x is equal to a times b to the power x. What is your initial value or y-intercept? Which is 5. Substitute y is equal to 5 times b to the power x. To be able to find the to be able to find the b, you can choose any ordered pair. I would like to choose this. 2, 20, x value is 2, y value is 20. Substitute 20 is equal to 5 times b to the power 2. If we divide both sides by 5, b squared will be equal to 4. Take the radical of both sides, b is equal to 2, which is greater than 1. That's the reason this is exponential growth. So we determined that. Next question. Does this function represent exponential growth or exponential decay? Ladies and gentlemen, to be able to understand exponential decay or growth, you need to determine exponential ratio and exponential factor. What does that mean? Y is equal to 5,575 times 1 plus something. This is r. We don't know what it is, to the power t. Because what was the formula? Exponential decay or growth. F of x is equal to a times 1 plus or minus r to the power x. If it is plus, then you will understand that this is going to be exponential growth. If it is a 1, if 1 minus r, then you will understand this exponential decay. So this is 0.65, which is less than 1. That means that this is going to be written y is equal to 5,575 times 1 minus 0.35 to the power t. As you see here, this is decay factor. And decay ratio is, this decay rate is 0.35. That's the reason this is exponential decay. Again, why it is exponential decay? Because your exponential factor is less than 1. What is your initial value? Initial value is 5,575. What is the rate of growth or rate of decay? As I told you, this is called decay rate. Rate of decay, 35%, or 35 over 100, or you can say 35%. Next question. Does this function represent exponential growth or exponential decay? By looking at here, you can understand this is greater than 1. That's the reason this is going to be exponential growth. How am I going to write this? Y is equal to 100 times 1 plus 0.25 to the power t. As you see here, this function is going to be increased by 25%. What is the initial value? Initial value is 100 And what is the rate of what? Growth. Because there's going to be, this is going to be growth rate. Why? Because growth factor is greater than 1. Rate of growth is 0.25 or 25 over 100 or 25%.